Hello, welcome to In 5 Minutes. Next, we are dealing with an common emitter NPN with dual source. What you can see in the diagram over here, you have two DC sources, V plus and V minus, so that it is called as dual source. Why it is called as NPN? We always find the arrow from P to N, so it is NPN transistor. Why common emitter? We are giving input to the base and we are taking output from the collector. So which terminal is left out? That is common terminal. So it is common emitter configuration with RE bypass. You can see a capacitor connected across the resistor RE. So it is called as bypass RE. Now the question says, for the circuit shown in the figure, beta is given as 100, VB on 0.7, VA 100 volts. That means we need to consider small arrow. They have told us to determine the small signal voltage gain, that means AV. Then determine the input resistance seen by the signal source. So including the source resistance, how much is the input resistance? We can say RIS, and the output resistance looking back into the output terminal. These are the three things which we need to find out. Now to begin with the analysis, what is our first step? We draw the circuit under DC operating conditions. So in that case, what we do, we remove all AC sources. So what would be done in this case? This voltage source will be replaced by a short circuit. Next is open circuit the capacitors. This capacitor will be open circuited. This capacitor will be open circuited, right? So how your circuit will look like under DC operating conditions? Like this. What you can say, when you are open circuiting, this part will be removed from the circuit. When you are open circuiting, this will go from the circuit. And if you have a capacitor over here, this part would have also gone out of the circuit. So you are left with this much part of the circuit for DC analysis, which is drawn over here. Now in DC analysis, we apply KVL to the base emitter loop. Again in AC analysis, you can do it in the shortcut fashion. Say IBQ, identify the base emitter loop. This is your base emitter loop. How many voltage sources? VBE and this V minus. So minus VBE, right? We are living with negative sign and we are living with positive sign. So plus 10 divided by, what is the resistance? This is RB. For example, if I am calling, so RB plus 1 plus beta times RE. This is the total resistance. So when you substitute the values, it will be 10 minus 0.7 whole divided by RB is 100K. Beta is given as how much in the question? 100. So 101 into RE. RE is 20 kilo ohms. So this will give you the value of IBQ as 4.386 microampere. Now once you know the value of IBQ, you can find the value of ICQ. How you are going to find ICQ? It is nothing but beta times IBQ. So what is the value of ICQ? 0.4386 milliamperes. Now once you know IBQ, ICQ, what you can find? The components required in the AC analysis, that is R pi, which is beta VT upon ICQ. So what will be the value of R pi? 5.936 kilo ohms. Once you have got ICQ, you can find R pi and GM. What is the equation for GM? GM is transconductance, current upon voltage. That will be ICQ, you know, 0.4386. VT is 26 millivolts. So 0.4386 into 10 raised to minus 3 divided by 26 into 10 raised to minus 3. So this will give you GM as 0.0168 amperes per volt. Now in the question they have given us VA. So if you have VA, you need to find RO. RO is VA divided by ICQ. VA is given as 100. You know the value of ICQ. When you substitute, you will get the value of RO as 227.99 kilo ohms. So you have got GM, you have got R pi, and you know RO. So these values are required for the AC analysis. Now what is our next step? We draw the circuit under AC operating condition.